Now that we have treated the problem as a vector addition and we have reformulated into an addition parallelogram, I think we are ready to find some numbers. So just to recap, this is what we know previously. If we have a plus b equal to c, and we know everything about a and we know everything about b and how they are oriented with respect to each other, we can find the magnitude of c using this formula, and we can find its direction with respect to this angle, beta, using this formula, right? So we can make an analogy of the situation that we know well with the formulas to the situation that we have here. So I can say that this delta RBA, the displacement, is analogous to C, and the vector RB is analogous to a vector B, and the vector minus RA is analogous to the vector A. The choice that I make here is I want to make an analogy that minus RA is A, not B. That's my choice. You can do the opposite, and if you stick with the formula and the form that you already know, you should be safe. But right now, let's roll to the decision that I made here. So, with that in mind, I'm just going to translate this formula to the situation that we have. So the magnitude of C is the magnitude of the displacement that I'm looking for, and therefore it's going to be equal to square root of RA squared plus RB squared plus 2 RA RB cosine some angle. And we have to be careful here. This formula is theta, but is this theta the same as this theta? The answer is they are not the same. If you inspect this parallelogram carefully, this theta is within the cone that is made by the arrowheads. B's head and A head make a cone, and theta is within it. It's within the angle between the heads. What you have here is this one. A head is there, but it's not there, right? The head is actually here, which means the proper angle that we need to use in this formula is this one. But the problem names this angle theta, but that doesn't prevent us to name this angle differently, right? Let's call it theta prime. So this must be theta prime. In order to use this formula properly, it must be theta prime. And what is theta prime? We know that the angle of a line, a full angle, is 180 degrees. And theta takes already out of that by 60 degrees. So therefore, this guy is equal to 180 degrees minus 60 degrees, which is equal to 120 degrees. Hence, the right way to use this formula is this with this angle. So, let's pop in the number now. RA is 6, RB is 4, 2, 6, 4 cosine 120 degrees. You have 36 over here, plus 16, plus 48 of the whole thing. Cosine 120, what is it? Cosine 120 is equal to cosine of 90 plus 30 degrees. Cosine 120 is in the negative zone. That is 120. That's cosine. So you need a minus sign if you want to use a sign by eliminating this 90 degrees. So cosine 120 is equal to minus 1.5. So you have minus 1.5 over here. You have this 52, you have this minus 24, so you end up having 48 inside, 28 inside the square root, and that comes to 5.29. I want to point out something here as well. If you design differently, let's say that you make an analogy that RB is A and minus RA is B, it would not affect this at all because they are interchangeable in this formula, right? If you end up having RB here, A will be there. If you have B here, A will be there. So the choice, whether RB is equal to B or A, doesn't really matter in this case. We have the magnitude now. Let's find the direction in the next video. To enforce your learning, write, comment, or share what you have learned today and hashtag PhysicsLitUp. And subscribe to Physics Lit Up for the next video.